Two, one. Hello, everyone. Welcome back to our YouTube channel, Becoming a ROS Developer, here at The Construct. My name is Rodrigo, and today we have one of our students, Utkarsh, who has completed one of our courses, ROS 2 Basics, in 5 days. And at the end of this course, you can complete a project in order to get one of our certificates. And this project is actually implemented in a real robot. So that's what we're going to be seeing today from our student. Hello, how are you?
I'm good. Hello,
Uh,
YouTube.
nice to see you. So
Yeah,
yes, whenever you want, you can share your screen
share.
with us and
Okay.
just tell us how you've done your project.
Okay, it says host has disabled screen sharing.
Oh, let me enable it real quick. You should
Yep.
be able to now.
Okay. Yep. Is it visible?
Yes, we can see
Okay.
your terminal. Cool. It looks dark. I like that. It's a nice
Yeah,
theme.
dark mode is the best. Okay. So so I built the package. My package is named wall follower,
Mm-hmm.
and I have a single launch file that will launch.
All your programs.
Yeah.
Cool.
So the robot has started finding the minimum distance to the wall,
Uh-huh.
uh, and now it's turning back. It did its second turn to move on to the wall falling behavior. Okay, yeah.
All
So
right.
I would have liked to tweak it a bit more, like to increase the speed, I guess. But
That's all right. I mean,
yeah,
the main point is covered here. So then the
yeah,
first part you said was to find the wall, right?
yeah.
And that was done, and
It's
now it's going
doing
around
the
the.
following behavior while it's recording the distance. So it will stop as soon as it's complete a lap.
Okay, and that's what we see in the terminal output,
Yeah,
correct?
yeah.
Okay, nice.
So yeah, it's using the Euclidean distance formula to calculate the distance and saves it in a variable and keeps publishing it.
I see.
Yep.
There we
Okay.
go.
Yeah. It stopped. Hmm. So yeah, that's close to a lap. I think should
Uh-huh.
have
Yeah,
gone a
yeah.
bit further, but
That's
yeah.
fine. It's
Yeah.
not that important. And
Mhm.
do we have a result here? Is there something that the program spits out or that you can use later?
So it does print out the geometry message. As you can see here,
Uh-huh.
I'm not sure if it's
Yeah, no, I see it. So
yeah,
so basically what are these?
all the points that have been collected.
Okay, so the points that the robot traveled through.
Yeah,
All right,
the
awesome.
odometry. Yeah.
Great, awesome.
Yep.
So yeah, can you just explain a little bit how
Okay.
specifics on how you solved each part and yeah.
Okay, so I have a presentation. It's a bit short,
Great,
but
awesome.
yeah. Okay. So yeah, as you know, it's the ROS to basics using Python. And at the end, we require to do a ROSject, which is which mainly focuses on being able to use an action service and client. So this is how the action server and client communicate. It's basically a service and a topic combined into one. So you keep getting feedback, and it's not like a service which just stops at like you just get a response at the end. You can get a feedback while the action is being executed,
Mm-hmm.
and you can cancel the goal whenever you want. Which is not the case with a service. Service is usually used for a very small task that doesn't span over a huge time period. So you know what's going on. So when you use an action, you know what's going on. If it's a longer period, and you want to like make sure your robot is doing the thing it's supposed to do. So yeah, the wall finder service is basically, so there's three threads. I'm using three threads. There's the laser callback function, find wall callback function, and the publisher. So
Mm-hmm.
you need the three threads, because if you don't have multi-threading enabled or use the reintrant callback group, uh, its default callback group, like the multi-threading, is done using mutually exclusive group, which will just execute one callback, and it will uh, like take the control over the entire program, and the other callbacks won't execute.
Mm-hmm.
So you need the multi-threading approach here. So yeah, my future improvements would be like, right now, uh, if there's if it has to turn to the minimum distance, what it would do is do always a clockwise motion, but I would like it to do an anti-clockwise if that's the smallest distance it has
Right.
to travel. Yeah.
Right.
Also, I dabbed in a bit of statistics, but I mean, I tried it before, but in the end, I didn't have enough time to implement it. But I got pretty good outcome with using a Gaussian curve. So what I would do is uh, plot the Gaussian curve for the entire laser index, uh, on, and then I would, uh, so there would be so there in a Gaussian curve, there's standard deviations. So you use that to calculate what's the, so okay, let me start by uh, portraying the problem. So the problem right now would
Mm-hmm.
be that you have the wall and there's a small obstacle right in front of it that's at the minimum distance
Right.
instead of the wall. So what the robot would do is go to the wall, go to the object instead of the wall.
Yes.
So, but so how a Gaussian curve would solve it is like the wall would have a bigger, like a bigger curve, or there would be more laser indexes pointing towards the wall, or there would be more minimum distances to the wall compared to the object. The object would just have, suppose, three indexes that are minimum. The wall, however, would have a range of indexes that are less. So yeah, I mean, it's complicated. That's the reason why
No, I
I
understand.
dropped
And
it.
it's not a
Yeah,
requirement.
yeah,
So I understand.
yeah. So I also tried using single thread. So what I would do is, I mean, it's not the best approach, but I tried like maxing out a single thread, like if I could do it with a single thread or not. I
Yeah.
mean, like in Logic, the multi-threading is basically required for the uh, odometry recordings. That's when I had to switch to multi-threading approach. Before that, what I would do is uh, have the laser index. Like I would just get the laser index once. I would then use that to calculate the time it needs to turn. And so it's basically dead reckoning where you don't use the sensors that are external to the robot. Like a LiDAR won't be part of a dead reckoning. It just uses the gyroscope and accelerometers. So, but in my case, what I did was I was use the laser list. I would get the minimum distance,
Well, you
find
use it
out how,
there, right? At that moment,
huh?
you're using the LiDAR. You're
But I
using
would
one
just
value.
get it for a single,
I understand.
uh,
Yeah, yeah.
yeah. I won't keep calling it back. I would
Right.
just get the laser index once. I guess, yeah, you're right.
So
But
if I understand,
the approach is still single threaded.
right,
I
right.
guess I I missed the dead reckoning. But yeah, the approach was still single threaded at the time, and I used the laser list. If you have a specific question, yeah, you can ask me.
Yes.
Uh,
So if I understand correctly,
yeah,
uh, I have a couple questions. First,
okay, yeah,
uh, if I understand correctly, the only place where you implemented multi-threading in a callback group is in
yeah,
the action server.
yeah. I mean,
So
I
then,
switched it over. Yeah, I basically started from scratch to do the action server because the methods are very different if you use a single threaded approach.
right. And then, so if I understand, you don't have that in your service server.
Service server. Uh, so my service, I didn't get your question exactly.
So, all right, you have
Okay.
an action server, right?
Yeah.
And what is
Yeah.
that action server doing?
So the action server is basically uh
Is
like
is it doing everything?
yeah, except the
So,
wall finding behavior, that's just a service.
yeah, that's what I was asking. So your
Yeah.
service server then finds the wall,
Yeah.
and that's dead reckoning.
No, that isn't. I mean, I switched over to multi-threading
Oh, and you changed
as
everything,
said
and
in the
you.
previous slide. Yeah.
Oh, okay, okay.
Yeah.
So I
I guess I
misunderstood.
confused you. Yeah. I shouldn't have brought that up, I guess.
So then
But
your
that
wall.
was a major part I tried doing on my own, the
So your
single threaded. Yeah.
so your main wall following.
Yeah.
I'm assuming. Do you have three programs? Basically, can we take a look at the code
Sure.
here?
Sure.
So it's a little more understandable.
Sure.
Right. Yes. So in here you have three programs, right?
Yeah. Yeah.
And I'm assuming that's what I was asking. You have in this wall finder, you have a multi-threaded executor, and I
Yeah.
already saw it.
Yeah.
And then and the wall following is the same, right? In
Yeah.
the other one.
Okay. Yeah.
Okay, I see. So you tried. What you're saying is you tried to do this without that, and then at
Yeah.
some point you gave up and and moved on to
Yeah.
the other part. All right. Okay, I
I
see.
did. Yeah.
I see. I see. Great.
Yeah.
And I guess one comment I have is based on the presentation you have.
Yeah.
So I maybe it's a misunderstanding on my side, but on your first slide, you talk about it's an action server, right? In your intro slide, number one,
Okay.
action server ROS checked.
Okay. Yeah.
Well, that's a little
I
more
mean,
than that,
yeah.
right?
Yeah. True. Yeah.
So you have a service server that finds the wall, you have a main node that goes around the wall, and you have an action server. Action server just happens to be the last of the things
Yeah.
to
True.
kind of showcase what you can do with ROS. Um,
Hmm.
and so yeah, I just want to make that point just to remove
Yeah.
any
That's true. Yeah, I
misunderstanding
should change that. Yeah.
that might be happening, because you actually did more than that. And
Yeah.
I mean that's pretty much it. Let me see if I can think of anything else. So
Yeah.
you said you'd use the clearing distance, and you wanted to be able to differentiate. You even provided an example how you could differentiate between an obstacle and the wall in your service server. And so I think that is good. That's great. That's a great way to improve it. Yeah, it would be to do that, or to check how many points. The simplest way is how many points the obstacle has. Right? If it's a
Yeah.
lot, it's a wall. If it's got a couple, it's something else.
Okay. Yeah.
But yeah, I understand that. And um, I guess that those are all the comments I can think of. I mean, it
Okay.
looks like from what you saw, though, looks like that code, for example, your code for the wall falling. I'm not gonna go over it line by line, but it seems super long. Is there a reason why? Because how many lines is that?
I think that's
279. All right, that's good. That means you really, grinded in it. And I see a lot of
yeah, there's a lot of comments as well.
comments, motion, but that's good. I mean, this is good. But yeah, I guess a suggestion would be to try and condense this as much as you can, because then later, once you have 70 notes, it's gonna be a little bit of a trouble here. But that's just a comment, and it's just it can be ignored. But other than that, I mean, Utkarsh, congratulations! Really nice project, really simple.
Thank you.
But yeah, I just want to make those. I just wanted to make those comments so you
Yeah,
get
those are
the
great comments.
concepts clear of
Yep.
what you took out of the course, which is just how to implement the three things: topics, services, and actions.
Action.
Other than that, I saw good practices in there. For example, your lighter callback, which was small, which is nice. That means less things to do in the callback. And I thought it was interesting that you talked about the debt reckoning and how you tried to implement it. I guess you could make it work with the find wall service.
Yeah. Yeah.
But I really struggle to see how you could move on to the next part, which is
No,
to follow the wall.
Yeah, that won't work.
Yeah. But I think it's interesting, but I would not recommend it for sure, because that's the advantage of having a sensor,
Yeah.
taking
That's why I
action
switched,
based.
because then there's no point using the LiDAR.
But anyways, that's a really nice presentation. So thank you again for showing us what you've done here.
Yeah. Yeah, thank you for letting me present
All right.
on YouTube Live. Yeah.
No problem. So let me go here and switch my screen back to me. But yeah, that is it, guys. This is what you could do when you complete our course, is to create a project and come here and present it and defend your work and explain it how Utkarsh has done it here. And I recommend everyone that is watching to do the same. And yeah, thank you again one more time for presenting, and we hope to see you again in the
nav stack, probably.
In the navigation too. Yes, I look forward to seeing you there. Thank you.
Yeah, thank you for letting me present, and thank you for your time.
All right, everyone.
Bye-bye.
So that's it for us, guys. We'll see you guys in the next presentation. Bye-bye. All right, cool. We